Awesome. So welcome everyone. This is the first GraphQL meetup in Zurich after, I would say, 2 years or so. I have taken over the GraphQL user group, I think, 2 months ago. And then we slowly started to essentially collect companies who want to host us. And thanks to Digitec for hosting this first meetup here. So give a clap to our host. So let me do a quick intro, and then we dive into the first talk here. So what is GraphQL Zurich? It's essentially a meetup for GraphQL folks. And what we aim to is to bring people really together again on this topic of GraphQL. And we want to do that by traveling around with the meetup. So we want to go to several companies that are doing GraphQL. And so everybody gets a look into maybe the work of that company or what they are trying out with GraphQL. In today's meetup, we will have a talk from the Digitec people. And at other meetups, we will get a window into these other companies. So what we also want to do is show what really is happening in the GraphQL space. So I'm a GraphQL TSC. I'm working on the GraphQL specification. And I will try to get a lot of people involved that are also not from Zurich, so that we always get some insights that what is happening elsewhere in GraphQL. So we will have international speakers from Netflix and from other areas like maybe Meta and things like that. So wait out for that. And another thing is, let's try to transfer some knowledge between all of us. So every one of us is figuring out GraphQL in his or her company. So it is a great opportunity then at these meetups to share ideas around this topic. The idea behind these events is that, as I said, every event is in a different location. Each event will have 3 talks, and each talk is 25 minutes. And that is done so first you don't get bored with a topic that's over an hour, with a really deep dive that you're not interested in. So you have 3 talks, 25 minutes. If you don't like a topic, you will endure with a beer maybe. But in every meetup, you will find one topic at least that you like. And it's also an encouragement if anybody of you, or maybe out there on the stream, wants to do a talk at the user group, it's not so intimidating, right? 25 minutes, I can fill that. And if you need ideas for topics, you can also reach out to the organization team. So it's me, Michael Stipe. There's Rafi, he's our tech guy for today. And there's also Jose here, so you can reach out to us via email, via the meetup site, or even just chat with us. Okay. So how can you help? Become a host. If you have a company that is doing something with GraphQL, become a host for one of our events. Easiest way to get involved. Or become a speaker at one of our events. Tell others about us, so share the knowledge that this meetup exists so we get more tractions to it. So this meetup is pretty full, so I'm very happy about that a lot of you really showed up. I've done other meetups where half of the audience didn't come. It looks that this is not the case with our event here. Also, if you want to keep in touch with us, we have a Twitter account. You can join us on Twitter or on YouTube. We are live streaming this event. And we will also edit the video feed of today. And then you can rewatch the topics online. Our next event is also scheduled. It's at Swiss Life in February. So Swiss Life, if you look from the outside, this insurance company, the pension company, they also call it the Rentenanstalt. English-speaking persons don't know that. Sounds not so interesting, but they have one of the most modern tech stacks I have seen in recent years, and I'm contracting there, so I help them a lot getting along there. So it will be really interesting. And we already have our March event. It's at Felfel. Anybody knows Felfel here? Okay. They are doing a pretty good cappuccino there. So I would come. They're all about food. So also a pretty nice event. It's in March. So we already have stacked a couple of events here and with really interesting speakers. So check out our meetup site for that. With that, we're getting to the first talk, and that is two people at Digitec. That's Andreas, Caspers. You can see them there already. And with him, his partner in crime, which is Andras Köpe. Is that right pronounced? Which will be at after I'm finished here. After that, we will have one speaker from Swiss Life. It's Martin Artola. And he will tell us all about powering your front end with GraphQL in React. And after that, I will also do a little talk on the future of GraphQL. So I will tell you a couple of things that we are working in the spec team for the next GraphQL spec release. So I give you a window in what's coming next in GraphQL. And there's one more thing. We also host the .NET user group. So if you're interested in .NET, then you can also look us up at the meetup site and look for the .NET user group. But with that, I'm done. I'm vacating my space here for our first speakers. So give an applause to our first two speakers. You need a switch on the mics.
Okay. So seems ready. Yeah, looks good. Camera is working, I guess. Hope so.
Well then, welcome everybody. I hope you could all enjoy a drink or maybe a coffee. Andy, how was your coffee?
Dark and bitter, as always.
Yeah, sounds just like graphical development at Digitec Galaxus.
Yeah, funny you should say that. I realized that as well, so maybe let's have a look into it tonight.
Yeah, but first let's check out our use case for today. So this is the product detail page. I guess you all know that already since you are here. This is the product detail page of Galaxus. And as you can see, we show a lot of different data here. Price, product data, ratings, availability. And today we will talk about how all this data comes together and then how all this data gets sent to your browser. Andy will show us how this should work, and then I will talk a bit about how it actually ended up working. Now, why you should trust us? Well, first of all, we have Andreas Caspers here. He is a software architect at Digitec Galaxus at the online shop area. We also call him Mr. Ivory Tower because he really knows how to talk about the real work. And then myself, I am Andras Köpe. I'm a software engineer at the before mentioned product detail page team. And my self-appointed nickname is Master of MVPs because I'm the one who ends up doing the real work. So Andy, what's GraphQL all about?
Yeah, GraphQL at Digitec, it's pretty easy, as you can see here on the screen. I mean, most of you probably know how GraphQL works, so I will keep on focusing on the parts which are maybe how we implement it or how it's running currently. So on the left side here on the screen, you see the client applications, that is the web page or the native mobile apps connecting to the GraphQL layer. So the GraphQL layer is handling all the requests coming from the clients. It's currently implemented with the Apollo Gateway based on Node.JS. Can access a Redis cache to cache certain data, And in the backend, we have, like Andras mentioned before, we have different vertical slices, domain-driven design-like, where we implement all these different features. That's here the three boxes you can see here on the screen.
Well, this looks good. It has been working for 5 years. What's the problem?
Yeah, there's not just one problem. We have several problems currently with this approach. First of all, we have a pretty monolithic structure. This is something which grew over the last 5 years. It started very small as a proof of concept, and then it grew and grew and grew. And now we don't really have a proper graph because it was not very well designed from the very first beginning. So a lot of requests feel more like we are talking REST over GraphQL, and not really, we don't have a proper graph and working how GraphQL is intended. And very often it's, I don't know the English word for that, it's more like a Durchlauferhitzer, which means it doesn't add any value. It's just taking the requests from the client and then asking the backend services via REST for some data, packs it into a GraphQL response and hands it over to the client. So one very specific problem we have as well is performance. As you can see here, we have a small screenshot of one of our tracing apps. What you can see here is GraphQL eats up a very big amount of time of the overall latency. So it can be that the backend service needs maybe 2 milliseconds to provide the answer, including the database access. But GraphQL then adds another, I don't know, 100 milliseconds on top, just doing anything, what a Durchlauferhitzer sometimes does. But as I said, maybe not everything is implemented well. And since Apollo Gateway is based on Node.JS, we have specific Node.JS issues. So currently in production, on average, we have 350 running pods where the Apollo Gateway is running on. And here you see a small chart regarding the event loop delay per second from Node.js. And I think you should investigate it if it's higher than 20 milliseconds or so. So you can see maybe we are a little bit over the top here. Yeah.
Well, can we do any better?
Of course. In the Ivory Tower, nothing is a problem. We can fix everything with PowerPoint and a design tool. So maybe that's why we're here tonight. Let me show you how the solution will look like. And as you can see, it looks pretty much the same if you don't read the text in these boxes. So on the left side, the web application, the native app, it's pretty much the same. It accesses our GraphQL endpoint, but the next step will be we don't use GraphQL Gateway, but we use Apollo Router. So together with Apollo Router, we are using federated GraphQL. So we don't have a so-called GraphQLit in the middle, which just executes REST requests to the backend modules, but instead the whole GraphQL layer, the GraphQL servers are moved to the backend services. So one thing Apollo Router then does is just taking everything together, build a nice, wonderful graph, and provide this to the clients. So we learned in the last 5 years a lot of things which you should not do when you design your graph. And this is something we think we have now a little bit of experience and how to do it better. And this is something which we strive to with this new approach. And I mentioned the Node.js approach. And no, this is not a stock photo. Yeah, this is a real screenshot. I hope you cannot read everything. Yeah, so yeah, that's maybe we can call this maybe legacy software or something like that. So and the last thing what we want to achieve with a new federated approach is to gain performance. Node.js doesn't seem to be the right solution for our environment, so we are currently, do everything, or the federated approach is based on the Rust-based Apollo router.
Well, I have to tell you guys, I really like Andreas as a person, but I don't really trust him as an architect. I mean, you are promising reduced complexity and better performance both at once. Is this really possible? It kind of sounds like a scam. But to look into this, we wanted to do some investigation into this. As you can see, this is the same use case as before. We wanted to find a use case which is pretty simple, but where multiple data sources get combined, because that's the whole point of using GraphQL. And first, we wanted to look into how our new queries would look like. And as you can see, it looks quite simple. We have one single query where we put all our fields into it, and then actually it gets resolved by the server. Previously, we had to execute two different queries to load all this data because of the REST backends. But now, with a single query, we can basically load everything. Then how do the objects get combined in our backend? As you can see, we wanted to combine the product data, which is exposed by the product display backend module. And we wanted to combine this with our community module, which exposes the ratings data. And as it turned out, this is quite simple as well. With a single line of code, we could tell our system that the ratings are part of the product scheme. And then both backend modules can expose the subgraph, which then can be loaded by the Apollo router and combined into one supergraph. And on the supergraph, our clients can basically query and execute any query they like. Then how does the data get resolved? Again, we have the same query as before, where we try to load the product and the ratings data. And by the Apollo router, which knows where he can find all these data parts, it will be split into two, and then forwarded to the respective backend module. So the product data part will be forwarded to the product display backend module, and the ratings part will be loaded from the community module. And at the end, well, it gets combined into one single response, and it will be sent back to the client. Now, if we look a bit into our previous solution, so this is the old system, hence it's black and white and with Times New Roman. As you can see, we had to execute two queries here. So we already started with two GraphQL queries, and then they were sent to our backend modules. But because of the REST API, we had no idea which fields are actually required. So everything was loaded there. We sent back in our response huge documents, huge responses, even though in this use case, we are only interested in the name and the price of the product. So Andy, I have to tell you, reducing complexity, this seems to be true. This is one check for you. Next, we wanted to look into performance. That was your second promise. Here, as you can see, this is scenario 1. This is the old system using the GraphQL gateway and REST APIs in the backend. And we wanted to compare this with our new system, scenario 2, using the Apollo router and then exposing all our data from the backends over GraphQL endpoints. And now, if we compare these two, as you can see in scenario 1, the numbers were 40 requests per second, and with an average latency of 500 milliseconds. And in scenario 2, we had 424 requests per second. So it's a huge performance boost, and the latency was only 70 milliseconds. For this test, we use in both cases our test environment with one single GraphQL pod.
Maybe one thing to add, which we didn't put on the slides, is what technology we use in the backend. We are using C#.NET. That's for most of the backend modules. This is the language we are developing in. And of course, since we are using C#, it's pretty obvious which library we choose for implementing GraphQL on the server. It's Hot Chocolate.
Spoiler alert.
Yeah, so
But we thought that these numbers are a bit dry. You can't really see how big the difference is, so we decided we will make it a bit more visual. So let's say with one request we can earn 1 Swiss francs. So that would already mean that in the first scenario we only earn 40 francs, in the second that would be already 424. And now if we take into account that according to Google, faster web pages can generate more money, then we can count into the latency difference. So I have to tell you, Andy, we're gonna get rich.
good point. And if someone else want to get rich, want to get some part of it, of course, we are always searching for GraphQL experts, but that's a different story than them.
Well, the numbers speak for themselves. We can see which is the better solution and which is the way to go. So again, back to your promise, I have to tell you the ivory tower vision seems to work. Better performance, reduced complexity, they are both achievable. Andy, what's next? What are our next steps? How does the roadmap look like?
Yeah, of course, it would be nice if 100% of our system would already exist in just the new world. But yeah, it's always the same with legacy systems. It will take a while. So the first step now is we have some low risk use cases are already in production. Low risk and low traffic to get a little bit of experience. That would be is the current state. And now we are in the process of first make the change easy. And then in the second step, make the easy change. So making the change easy means we need to build up all the knowledge about what is a federated approach, about the libraries, how to introduce it in the different feature teams. We need to build up and operationalize the infrastructure with the Apollo router on as the central part, which is accessed from outside. And also on the client side, we have some. Currently, we are using most of the time Apollo client, and we are now investigating is this also a good choice for the future development, or will we change this a bit? And yeah, we think that we will throughout the year we are going to replace maybe around 80% of all the requests. They will be then shifted over to the new federated approach to the new supergraph.
Are there any questions?
Questions?
Yep.
This Apollo router, what is the technology that you use to make this system?
The technology, you mean in which language it's
exactly,
implemented?
yeah.
Yeah, it's based on Rust.
Okay.
Have you measured the performance of a composition? So how much time takes the router, how much time takes the backend service?
Mm-hmm.
Could be pretty interesting.
I don't have the exact numbers in mind, but the overhead was really nearly not measurable. It was really, really fast.
You mean the one from Rust?
Yep.
Yes,
Yeah,
so-
exactly.
Are you also using data loaders in the services themselves?
Mm-hmm.
Yes, yes, yes.
I see you have like awesome performance data about how your system performs.
Mm-hmm.
I guess you also do not have like only end-to-end numbers. You possibly also have just backend numbers. So if we take like the old backend that you have
Mhm.
with I guess Web API or something like that,
Yep. Mm-hmm.
and then you take the GraphQL backend,
Mhm.
what's the difference in response time there, if there is any?
So if you want to compare so let's say the REST APIs in the backend with
Yep.
our new GraphQL APIs, we also did some measurements. I don't have the exact numbers, but one test case was where we compared loading a few fields over GraphQL compared to the REST API, which, well, returns everything. In that case, GraphQL was actually faster. I wouldn't say a lot, but it was quite faster. If we wanted to load everything, so all the possible fields over GraphQL, then it was a bit slower. I guess this is because the overhead of the system and doing all the the compression, decompression, etc. And
Yeah, makes sense.
Yeah.
Yeah.
It's more to do.
Yeah, but it's not that much difference. I mean, we can save much more with a shift from the Apollo gateway to the Rust router and the hot chocolate approach in the back end.
Makes sense.
So,
How,
yeah.
how do you host the Rust stuff? Is this just still npm run, or is it more difficult than that?
I don't think it's that much difficult. I'm not the infrastructure guy or expert. We have some guys here which are doing this stuff. So maybe later on they can give you more detailed information. But I think we didn't invest that much time to configure everything. So yeah, I think it's in a Kubernetes cluster, as far as I know. But we didn't customize that much.
Okay, nice. Thanks.
How many of the APIs were repeated? Like, did you cuts the most common? Or?
How many APIs were repeated?
It's like if someone goes to the iPhone page, is everybody at the same time, you get the same request, probably multiple times.
No.
Did you cache the
Did you cuts?
Yeah. Mm-hmm. Yeah, that was currently we are caching some things in the Apollo gateway. So this is kind of a self-implemented caching approach, which is based on Redis. But the problem we have with iPhone, it works pretty well. But we have I don't know, a few million articles in the database.
No.
Okay.
Still after this one.
Okay, yeah, we have a few million articles in the database, and the problem is the distribution of the requests. So, iPhone is called pretty often, but a lot of other articles it's not really worth the effort to cache these things. That's the problem with this. Yeah, but for iPhone it works pretty well. Yeah, that's I think he was first. So.
that was almost also my question. First of all, I think it's really cool to see a federated graph approach. I think that makes a lot of sense, especially if you think about most queries are probably not going to ask for every single field that the REST API would have provided. But then in the beginning we had the Redis cache that was probably also caching a lot of the REST responses.
It depends on the content, because we have some data, I mean some article data, yeah, that takes a very long time until you get some new information, but prices, availability, these are the things which you cannot really cache, because then they are especially on high frequency days, it takes seconds until they are outdated, so they cannot really be cached. That's
I was wondering with the federated approach, what happened to the caching layer, and is there a replacement, or is that just you don't need it anymore because it's that much faster, or did it move to the client? But then again, you still need some caching for some articles.
Yep. It's still in the client. We already have some with the Apollo client. We have some caching. This will, for the moment, stay the same. The centralized caching approach will disappear, and it's now the responsibility of the backend services to cache the data. But this is, I think, or at the moment we think it's a much better approach, because the backend services, they know exactly how to cache these things. And with a generic caching layer, yeah, you cache everything, but the hit rate is not that good. So maybe.
Thank you.
Okay. So
We have one question from our live stream in YouTube from Predator. Is how can it be avoided, the malicious GraphQL request that would cause backend overload, like DOS attack or similar?
It's the same as with all requests. You have some, I mean, on the CDN layer. This is Akamai in our case. We have some detection for malicious requests. So this is handled in the same way like other requests as well.
Are you also using persistent queries?
Currently not. Yep. That would be also, yeah.
That's
Yeah.
the best way to
Yeah.
make GraphQL secure, by the way.
Yeah.
Assisted queries, and you don't have to worry.
Yeah.
Thanks to Predator for the good question. Also, another question from Stan Max Trovovic, if I pronounce that properly. Could you repeat the full tech stack you're using, hot chocolate in combination with Apollo?
Mm-hmm. Yeah, on the client side, we are using currently Apollo client, but we are investigating if this is still the right solution for the future. Currently, we're using Apollo Gateway together with Redis on the GraphQL layer, but this will shift over to Apollo Router. And on the backend, we are currently using just C#, .NET, ASP.NET, REST endpoints, and in the future, like you already mentioned, currently we started by using Hot Chocolate for implementing the Graph server on the backend modules.
What does the ivory tower see in the future of the front end?
So the ivory tower in the future for the front end just sees a blue box and asks the export or front end experts. I'm really not a front end expert, right. So I can't answer this question. We are currently investigating also Relay, but investigating. That doesn't mean that there's no decision yet. If it has a chance to replace Apollo client, it's really open at the moment.
Awesome. So we have 5 minutes to switch the speakers. That's awesome.
One question was...
Yeah, one question, if there's one more.
I have a simple question. Do you use the same approach for mutations or query, or do you use
yes.
different approaches?
Yep. Yep.
And you don't do any server-side rendering for your front end?
Yes, we do.
Oh.
Yeah, but we didn't focus on that.
And just the last one, between
yep.
this Apollo router and your backend services, do you still call over HTTP or do you use a different router?
Yeah, HTTP. Mm-hmm.
Awesome.
Yeah.
You have 5 minutes to get a beer while we set up the next speakers.
Oh.
And yeah, applause. Applause. And I think Martin will tell you all about Relay. So
that's a perfect handover.
As you mentioned, we have open positions.
Michael, come here.
So now we're having Martin. Martin is a front-end architect at Swiss Life, and he helped Swiss Life migrate actually from Apollo client to Relay. And for people who don't know it, Relay is actually the view of Facebook. Facebook is the inventor of GraphQL on how GraphQL should work in the client world. So if you're using Facebook, you're actually using Relay. So Relay is the client on which Facebook runs. And Martin will give us not a deep dive, but a quick dive into Relay. The stage is yours.
Hello, everyone. Yes, I want to be talking about front-end from the front-end point of view, how we do GraphQL, right? My name is Martin Artola. I work at Swiss Life. I am front-end engineer, and I help teams there to build and ship applications, right? Apart from that, I am a member of the Chili Cream team. And if you are using hot chocolate or banana K-pop, these kind of products, I am doing something there, especially in the front-end part, of course, right? Then let's move fast, right? The idea is like how to build applications that are ready for scale, right? Things that are ready to scale. We start small, like a POC, but then we need to get something in production, and we need to maintain it a lot of years, right? Then what really scale means, right? And scale means basically having the capacity, right, to support a growing demand, while at the same time we keep the same user experience. And we can especially have two things, right? The first one is very well known, that is support a growing demand of users, orders, any other peak demand, right? Like hot season and so on, right? And usually this, we know how to do it, right? We were used, and this is independent of the technology that we use, right? The other is more related to how we build the software, right? That is having the capacity to introduce new features or modify the existing ones, keeping the same cost, right? We don't want to slow down the system every time more and more, right? And this is, from my point of view, what is really difficult, right? How to build applications that are ready for scale, that the cost of the first feature is mostly the same as the next one and the next one some years later, right? And I think that we can do this by selecting and leveraging the right tools. That's why we were talking here, in my experience, and the experience of a lot of colleagues that are here, for example, we are using React, Relay, and GraphQL, okay? Then a small disclaimer, I am not your financial advisor. I will be showing some strange numbers soon and some other stuff that is a bit crazy. Can you read this small letter here?
Yes, sir.
Yeah, okay, that was the idea. If you cannot read it, it's perfect, okay? I am talking, for example, about this, okay? We have cryptocurrencies. We have collected these prices around 1 year ago, and the market was a bit better than today. Then don't run to sell now. Just need to wait another 10 years more, okay? This is an application that we used to build in the workshops. We do a workshop with Michael. We do the backend in hot chocolate, the frontend in React, Relay, GraphQL. And during this workshop, a couple of days, we build the whole application, backend and frontend, okay? And we use this application to do all the stuff, show a specific step-by-step how to do different things, right? It's all about cryptocurrencies. You can see a lot of lists of currencies and prices about them, but was just to show something that we can show all the power of GraphQL there, right? If we run the application, I am running now a version here in my machine. The application is this one, okay? I will just refresh. We can see the application there up and running, and it's, as I say, a lot of cryptocurrencies. It's an application that is done for teaching purposes, right, to learning purposes, not especially about the design of the front end or so. We have other versions in MAUI, and we are finishing one in React Native that will be also presented. But the core idea, especially, is about GraphQL, okay? And then we can see this application, and this application has a nice thing, right? That is, we get all the information using GraphQL. You can see that here I am showing the network panel, and we can see calls to our GraphQL endpoint, okay? And let's start with one of the first view, because I have a lot, and I don't know how I will run with the time, okay? Yeah, usually I do this in 1 hour. 35 minutes is not my best. Okay, then let's start with this view, okay? We call this the dashboard view, this one that we saw before in the application, right? And we have a lot of lists of currencies. Each of them, each of these components that we have here stacked in this view has different needs, right? The data requirements. For example, the first one is called a ticker, and we are showing 10 currencies there sorted in a specific way and so on, right? The same happened with this one that is called a featured, where we pre-selected 3 of them. And here we have a list of gainers and losers of the day, something like who is performing better or worse today, right? And when we see this in the application, we can see here, I will refresh the screen. It's exactly this view. We do one call, and one of these, really you can see 3 calls here. One of these is the query that provides all this data. The others are a couple of subscriptions to update prices or some other thing that we are running there. But now I will do here, right-click, I will copy this as a curl, and I will go to Banana K-pop. If you know Banana K-pop, is a GraphQL client IDE, something like graphical or playground, but much better. Okay. And you do that. This is a new feature that we are introducing soon. I just did paste there, and I created all the document, including variables, headers, and so on. And I can directly copy from what we have in the application, and I can, yes, run it and see exactly the same that we did before, right? We have the ticker and all the information, feature, gainers, losers. If I run again, you can remember this, we have gainers and losers in this order. Sometimes they come even different, okay? This is something that we will see here, maybe, maybe not. Oh, this time, look. Second run, I got the losers first and the gainers second, right? But what is this query? Okay, we are in the GraphQL meetup. You all know what we have here. I did the query by spreading the fragments, right? I have created fragments for each component, and then I create the query by composing these fragments one in the other. Good. Then, if we see here, for example, we have the first component, the ticker, and here below we have the ticker fragments. And you can see, do you remember this list of items that we have here that we call ticker? Each of these small ones is an item. And the list is a list of items, right? And in the query, we can see that we have, this is the item, and we split this fragment to compose the list. And the list say exactly here which are the ordering and some other information that we need to do. The same I did for the other components. You can see here the spotlight, these gainers and losers, and so on, right? And between them, we can see even this thing. In these lines, we have the gainers and losers, and here we have a directive, a GraphQL directive, the defer, right? And this is what allows us to, and that is the reason why we got gainers and losers in different order, right? Why we have this thing here, right? Because the view contains a lot of information. And like user experience, I want to focus in this part, and probably the losers is not so important. Then I want to prioritize this part, and the others could come maybe at the same time, maybe later, I am not sure. And now we are able to do this with differ. Before we were forced to do split the queries, right? One query first and the other later. Now we have the possibility in the language, in GraphQL, to say, OK, give me all of these. We have just one single request, but we have multiple responses. And this is what we can see here in banana K-pop. When I execute, we can see that we receive different chunks. When we receive the first part, then the second part, and so on, right? And you can see how the first part was including what was mandatory to have there, like the ticker and so on. And then I started to get the gainers or the losers and something else. OK? Then up to this point, we are talking about GraphQL, right? And the thing is like how we build these queries. We could do these queries by hand, run and start to write a lot. Even we could remove the fragments and do a super big query and put everything in one place, right? But this is what we don't want to do. We need to be a little bit smart. And now I will jump to show you here how we do first conceptually, OK? We will create these components. And we have this dashboard view. These are the most important components, right? Not the presentation components, right? We have the ticker, and we have the ticker item, and so on and so forth, right? And what I have here is what I was showing before. We have the query, and we have the fragments for each one, right? What we will do is specify these fragments co-located with the component. Then we will compose these components, and Relay will create the big query for us, right? Then let's see this in action. Here I have an application. This is the application that I am running. This is a Next.js application. You could use whatever you want, right? And the thing that we are showing now, scenes are views or screens, as you want to call it. You can see this dashboard container. This is a normal React component where we have spread each of them these queries. What we use is this hook from React Relay. Relay is composed of 3 parts, right? We have the Relay compiler, that is a build step that will verify and validate and optimize our queries. We will see a bit more in the code later. Then we have the Relay runtime, that is the part that will be running in the computer of the user, right? That is agnostic, is implementation agnostic, it's just plain JavaScript. And then we have React Relay, that is the bindings for React. In this case, I am showing this part, right? And in React, we use these React hooks, right? And then React Relay exposes some hooks. This is for doing queries. There are a couple of them, a couple of different ways. This is probably the simplest one, OK? Use lazy load query. How this thing works, if you want to see something of React, the thing is like, I do this query, and I get this data. Really, this assignment will only happen in the moment that the data is available, because this hook will throw a promise. That means that the execution of the code stops in this point, bubbles, right? And React catch it. And in the moment that the promise is resolved, the promise will be waiting for the data coming from the server. In the moment that the data is available, the component will re-render, and now my data will be available there. Then this is very nice in this API, in this React Relay API, that the code that we write looks pretty much synchronous, OK? And the asynchronicity is hidden in these hooks, OK, in how React works. This is the suspense API, if you know a little bit of React. Then the thing is like, as you can see, here I have the view composed. I define the components that I have there in the view, and nothing more, OK? And now if I go one by one of these components, we will see that the ticker, for example, is doing the fragment that we saw before. We have 3 kinds of fragments, of hooks for Relay. This is the simplest one, use fragment. And you can see that here I define how the list is with the sorting and filtering information, and I split the item, right? If I go now to the item, we can see that I define exactly in the item component exactly the data that I need there. If we see, for example, in the view, what I need for this thing. I need the symbol, I need the price, I need the color, a few fields only. And that is what I am requiring here, right? I am requiring the symbol, the color, the price, okay? And then I just render them, okay? Then the thing is like this. The thing that I did for the ticker, we have not so much time, but it's the same pattern repeated again and again. You can see the feature, and here we have the carousel with 3 images there. It's a list with 3 items, and the feature card contains inside the items, right? And the same happened with the gainers and the losers. We will see a bit more later, but it's just composing this thing, right? Then when we go here back, we can see that it's very simple to specify what we need. If I come here and I do a change, for example, something like, say, I will do a typo that maybe I introduced unintentionally, I save it. I am running like very simple here. If I run the command here, I am running in the bottom there, yarn relay. You can see that the compiler immediately found that there was a typo there and will not compile my code, right? The relay compiler is written in Rust, is super fast, and is able to generate typings for TypeScript, Flow, and just plain JavaScript, okay? That means that you can use TypeScript in your business applications. That's probably what you want, okay? Then here I am running the compiler by hand every time that I want. This is possible. Like developer, I do this a lot of times. But you can run it there in watch mode, and every time that you save a file, automatically will compile. Okay, this is depending on what you want to do. The thing is like, when I run the compiler, what is happening, right? Then let's see this fragment. The fragment is able to get the data from the query. Okay, it's able to extract from the big query the part that we need. And here we have a GraphQL tag, the same that we use in JavaScript in other libraries. And this is in the build process, we will replace this code because we will not send this to the customer. We are not interested to send this information. What we will do is generate code like we can see in these files here. And for example, the query is something like this. Okay? And you can see. Then we replace that GraphQL tag with our GraphQL query by this code that is something that is optimized for runtime. I mean, the application is built, is done probably with Webpack or some other bundler, right? And it's, even if it's an artifact in your system, right? Then does not make sense that we send the query to the client and then to the server, and the server need to execute it again, and the client again parse it again, right? Then we can do this in the build step. And then we, for example, we check against the GraphQL schema. The GraphQL schema is our contract that we are requiring the right fields and any kind of optimization that we can do in this build step in place of doing in the good. 5 minutes, ouch. Good. Then yeah, we'll run out of time for sure. Good. Then, yes, very fast here. I will try to show not so much because I have a lot. Let's go to some other stuff. Here I have a slide just to show the case of the differ, how we handle the differ when we have the gainers and the losers, right? The server will send us gainers and losers in any order, but we want to render them always in the same way. First the gainers, then the losers. This means about doing some layout. We can use React suspend list, and with these parameters enforced that no matter how the server sends us the information, they will be rendering exactly in that order. Okay? Then you can see how we combined React, Relay, and GraphQL to get the best user experience possible. Good. Let me go fast. Here I have another list. The difference with this one is that we have pagination here. Okay, in the middle we have pagination. Apart we have filtering, sorting, and so on. Maybe another meetup because for this one will be too much. Again, the same. We have the requirements, especially the pagination that I want to show. And let me show you the code very fast. Okay. Mainly in this part that we can see here, we have another hook that is called use pagination fragment. It's another fragment. And this hook is responsible for do all our pagination. This hook returns a bunch of properties like I am showing here and more. We have data and we have some helpers like we are paginated forward, then we have the has next. You can paginate forward or backward, right? You have the has next, has previous, load next, load previous, and so on. It's loading next and so on. Then very simple, every time that the user clicks the button load more or the button is at some offset of the screen and automatically trigger, this will be calling the next page. And this is because Relay support cursor-based pagination and GraphQL support it also, right? That was done especially in that way for that case. Then let's show here, for example. You can see here I have the load more button. This button was done intentionally like this. The first time, if it is in the viewport, I need to activate it. But from now on, every time that I arrive to the button, fires automatically and load more pages, okay? And the only thing that I need to do is pass kind of the on-click for the button, is the load next, load next, load next, and the page size that I want. And in that hook that we saw before, that is not so much, we have all the logic to do these kind of things. Okay, the rest is just spreading things there. Let's move fast to other topics. Yeah, this one I will just show you because it was there. Here is if we do filtering and sorting, we are able to keep showing the data while we are refetching. We are going for new data. We are asking the server for new data. Then we keep showing the same data, and this we do it with React start transition. Okay. Yes. Here, very fast. This is another view. This view is called viewer. Is when we click in one of the currencies, and we have mainly this functionality that I want to show. In the header, we can toggle. We can do a mutation. In this button, we can add or remove from the watch list. And here we have a subscription, okay? And the subscription is to get price updates. Look how easy it is to do, right? Here we have the mutation. I have created a custom hook that is just a wrapper for the use mutation. That is the hook from the library. And what I do is create my mutation, right? Just what I need to do in the operation. And here I can just execute it and say, okay, when it's done, what I want to do, right? Here I have a very simple setup. Mainly, probably you want to see this one, that in case of a like button or something like this, is an optimistic updater. That means that, for example, we modify the store, the relay store, that is what updates our component immediately while we are still going to the server. When the server comes with the response, this change is rolled back, and then we merge the change coming from the server, okay? And very fast, I showed the last, that is the subscription. And the subscription is super simple. Something like it's so complex, at the same time it's so simple here. For us, the only difference is like, okay, we need to write the keyword subscription, and we use the use subscription, Okay, this is a hook. It's so simple. Relay is agnostic about the network layer. You need to implement your client. I can show you very fast a client. This is a client that we write in the workshop, around 300 lines with comments and so on. We can, with this client, we can do over HTTP everything using server-sent event, for example, for the subscription. And even we have here a version of the client using WebSocket, if we want to use a WebSocket for the subscription or for everything. This is up to us. Relay is agnostic about the network layer. You need to write your own. Okay? You go from the simple one, we do it in the workshop, 10, 15 lines, and you are doing GraphQL. I mean, very, very simple. Okay? Let me finish. I am done. Sorry, I will have for 1 hour more, but...
He does, he really does.
Yes, the thing is like, let me go back to this one. Wow, one more. Sorry. The thing is like, we can do very simple if we choose the right tooling, okay? The tool help us. We need to be smart. We need to test our tooling before start to use it, especially in big projects, okay, where you will have a bigger demand to scale later, okay? And if you want to know more meetups or join us in some of the GraphQL workshops that we are doing next, I will be in .NET Days in Romania with some people that I saw here, and in Oslo in NDC. We go really deep there, really, really deep. Thank you very much.
Awesome.
Thank you for coming.
Other questions? Yeah, go ahead.
Okay. Yeah. Can you elaborate a bit on the delay directive? How and why it was used?
The differ.
Was it? Sorry.
The differ.
I show you differ.
Yeah.
Next talk.
I use a differ. That, you know how is the differ thing, right? The point is like, if we have a big query in GraphQL, the response will take the time that takes the slowest of the fields to resolve, right? And sometimes we don't want that. Then the differ allows us to give a hint to the server to say, okay, this part is not so important for me, and probably you can send it later. Doesn't mean that the server will exactly do it. Probably will just wait to send everything, or probably will implement something. Okay, that is about how the directives are or not supported in the server, right? And also depends in the data that we are requiring, because maybe the data is already cached in our Redis cache, right, or somewhere else, and we can answer it very fast.
That was, sorry, he was first.
Yeah, very impressive code, very impressive example of how to use GraphQL like modern GraphQL today. But I was just asking myself one thing: isn't there @stream now?
Yes, I will show you that. Next talk. Next talk. Martin could also show it, but the funny thing is, it was a very good presentation of Martin. And the funny thing is, I asked him in the beginning of last year, Martin, do you want to do a workshop with me at a conference? And I dragged him over the last 12 months to every continent of this world. And now he's really relaxed speaking here. So this should be an encouragement. So if anybody wants to also do a talk, we yes, get you there.
That's better every time.
Would be awesome. So go ahead.
Yeah, I have 2 questions. One is from Giorno Guevaru. What's the performance? How was the performance increase with .NET 7?
With .NET 7, so Martin is more the JavaScript guy.
Yeah, I don't know why he say that. Just relaying that. And the other question, also from Giorno, is did you do load testing?
Yeah, yes, we can do testing. I mean, that is what we should do in enterprise, of course. And you should take care how to test. We show in the workshop how to test GraphQL, right? And how we can do it, right? Yeah.
Also from Paul Hester, good job,
Yes. Thank you, Paul.
You know him, I guess.
Yes. Thank you, Paul.
Awesome. Okay. One more question, yeah?
Last question. Where can we learn more about Relay besides the official documentation
And our workshop, yeah.
and your workshop?
I mean,
There's actually the GraphQL Foundation is running a Discord server where all the frameworks have a channel. So if you go there, there's a Relay channel, and the Facebook team is curating it. So you get the answers of the Facebook team in that channel. So it's not seldom that Joseph Savona, I always get his name wrong, but he's one of the chief software engineers of Relay, and he will answer your questions. Sometimes 1 o'clock in the night, you think, when does this guy sleep? But it's very well attended, this channel. So I can post the link to the Discord channel into our meetup notes, and then you can just join this Discord channel, and there's everything that you find to any GraphQL framework.
I would say that Relay, the documentation for Relay is not so good.
No.
There is an official documentation. It's for enterprise, right? Then you need to think in enterprise way.
It's more like that. So
it's more like, yes.
No, Facebook built a Relay for Facebook, and then they thought, okay, we could open source it, but figure it out.
Yes, I mean, that makes that is not so easy to use if you are not in an enterprise where you have the people to do it, right?
Yeah.
I wrote the network layer for the company, and everybody use it, and nobody can make any change there, right? I mean, it's already done, and we have hundreds of developers using it, right? But what is interesting that the Relay team helps a lot. If you open an issue in Relay, you will get very good support with them. I worked with them several times. We introduced new things. Even there is a new hook in the next version that I required, and in the same day was introduced in Relay. I cannot get this in my company, right? Probably someone will not approve my pull request. I mean, yeah, sometimes, it's surprising.
So grab a beer, and I'll set up while you are getting ready.
I will say I cannot parse this thing.
Right.
I think I will sit there.
You will get there.
Yeah. He will return later. Good.
So, hi everyone on the live stream. We are starting in 2 seconds the next talk. We just, yes? Ja. So. Start mal den Beamer um. So, letzte Talk für heute. Meine Freunde von der Digitec, die das Ganze hosten hier, die haben mir gesagt, sie sind jetzt Pizza am Bestellen. Oh, sorry, English. As a German, sometimes you switch to German. So our friends from Digitec who are hosting this event and are paying for the food and the drinks here, they are ordering pizza. So after this talk, don't rush out. Wait, we have food, and also we all want to talk, all right? It's so awesome to meet all of you and have these discussions here. So after this talk, it will be maybe 25 minutes if I'm getting through it. We will have pizza. Is that right? Awesome. Awesome. So let's start. Yeah, the pizza will come after the talk. On the live stream, you have to make your own pizza. So, I want to talk to you about what's next for GraphQL. And so, as a member of the spec committee, I sometimes get the feedback of users that GraphQL is stagnating. And I want to tell you otherwise. That GraphQL is actually taking its biggest steps yet. So actually my talk is more about building modern applications with future GraphQL. So let's dive into it. So when we talk about GraphQL, it's or most times we're actually talking about optimizing our request. Essentially reversing control from the backend developer to the frontend developer. So typically, when I explain GraphQL, I start with this slide. This is essentially the hello world of GraphQL, where we, in this case, ask for the currently signed in user and for the name of that user. And if we send that to our GraphQL server, we typically get what we asked for. It almost looks like we are sending in an empty JSON graph and getting it filled up by the server. It's not like that. So you all should know that. But it's a good mental picture to start thinking about GraphQL. And that was actually the main intent behind GraphQL when Facebook started with it, because they had this problem of mobile applications that were doing tons of REST requests, and they weren't getting what they asked for. They were getting all this stuff that was designed for the desktop. And that's why the first application of Facebook actually sucked for your iPhone or your Android phone. And that's why we are all lucky today that we have GraphQL, because it sucked so much that Facebook started writing GraphQL. And if we dive into GraphQL, we actually figure out very quickly it's not just sparse fields, it's actually about graphs of data. And as we expect, also when we dive deeper into relations of GraphQL, we get exactly what we asked for. And when you listen to Martin's talk, he talked about fragments, or? Because fragments in GraphQL are essentially meant to be our data components or the contracts of our UI components. And that's important because they empower us. If you think about relay components, one like this, I actually have no clue of relay. I'm always copy-pasting of Martin, so this is Martin's code. And here you can see we have a fragment that actually defines the main data contract for this component. So I only can render the data that in my component code that I asked for here in GraphQL. And that's why it's so cool, because suddenly we're not thinking about how do I get the data that I did with that REST call into this part of my component. It's more I'm telling now in my component already, okay, this is the data I need to render my component. And then when I compose my components, actually I'm composing a GraphQL request. So when I talk about modern applications, I always show our example here. Why is it modern? Actually, because it really lives. You can see prices are updating here, and it feels really engaging for the user. But let me show you one thing. Let's go maybe into the developer view here, developer tools. Then go to Fetch XLR and refresh that. And what I can see here is, because it's so awesome to do it with GraphQL, I'm refreshing this whole screen, and you can see there's a lot of data to it, but it's a single call. And no matter what I'm doing in this application, it's just one call. So maybe I'm fetching here the prices of Uniswap. I don't even know what that is. But it's just one request of data. And maybe I want to have more data here. I don't want to see the daily graph, but I want to see the weekly graph. And if I dive into that, it's just one more call of data. And that's super efficient on mobile applications and also on desktop applications, because we do not block our browser with tons of requests. And also, like, network is treacherous, right? It's where everything gets slow. Because if I look at our server for this request, it actually tells me that my request was computed in under 10 milliseconds. But if I look in the network request, it's 200 milliseconds. That's network. And then it's good if I just have one request here. So GraphQL is designed in its current iteration for reducing network calls, for making it efficient to fetch data. But that brings some problems with it. Because if I look here into my modern application, and let me go to the main screen, we sometimes have here 600 milliseconds because we fetch all this data in one call. And that means I have to wait for the slowest part of my call. And if you look at that application, I have these graphs here. And if I slide to the side, I have a lot more graphs here. So when the user first goes on our site, he doesn't even know that there are more graphs here. So while I want to fetch everything in one call, it would be cool to tell GraphQL when to fetch what. And that's where the biggest effort at the moment in the specification group is focused on. So making sure that you can also prioritize data. Prioritize what you want to fetch or deprioritize it. So we want to empower the consumer of a GraphQL API even more. Give him control about what data he or she needs most. So with the new GraphQL specification, I hope it's the next version. Depends on what we find as blockages still. But it's something called stream. So it would be awesome if I could just say, yeah, I need these graphs, but maybe stream these graphs, and maybe I just need the Bitcoin first. Let's have a look at that, because Hot Chocolate implements the future already. So if you are using our framework, there also Apollo is doing a ton of work to get it also in. So if you are using Apollo Router, the newest version, they also support it. And works perfectly with Hot Chocolate, as we saw earlier. So this is banana cake pop. And by the way, there are cake pops if you are hungry. Cake pops are essentially cake on a stick.
Can you hold it?
So I need a photo, but I need to keep talking because pizza is coming. So the best feature, and I made them do it, actually is that we can move the sunglasses. Okay, no. We actually can do more. So let's have a look a bit about the request. So I'm pulling up here the request to actually fetch the charts. This is what we call when we open up our API there, our UI. Then we fetch here the assets and we get a ton of these percentage data, the graph histories to build up the graph. And when I call that, you can see already it's 1 second, not good. So now I told you there is something called stream, and I could say, actually, I want these graphs, but stream me these graphs and give me the first graph immediately because I want to display the first graph that you see. And then you can trickle in the data because until the user realizes he can swipe to the side, the data will already be there. That's the first thing. The second thing is that maybe I identify here slow parts. In this instance, I know this part to get the changes is slow because we are fetching in the background from a REST service. So I could use an inline fragment here or a fragment to defer this section of a graph. And I have to be quick because you can see my... But thankfully, my brother has a solution here. So I can defer also sections of my graph and say, okay, actually the graph data, if you don't have it immediately, give it to me later. And if I now execute that, I'm 249 milliseconds, not for the whole request, so we cannot magically make it faster. But for the first bits of this request, I only need 240 milliseconds, which you don't even see. So as a user, it's fast. It's there immediately. And if we dive now into our analytics here, you can see we have the logs here. You can see that we get the Bitcoin and the latest price first. And then if we go deeper, for instance, you can see that we at some points get here percentage data, and that's for the graphs to paint them. And we get the information where we have to patch that in. So you can somewhere here see that there is a path. And this is where I have to apply that into my graph. And actually, Relay implements that already for years because Lee Byron, one of the 3 guys at Facebook who came up with GraphQL, he told us about defer in 2016 at React Europe. And we at the spec group had to figure out how this can be implemented over the last 6 years. But anyway, Facebook is using defer already for a long time. That is why with Relay that already works out of the box. So this is awesome. But with great power comes great responsibility. And that's why it takes so long to figure out these features. Let me show you one more thing. So we were specifying this feature and we implemented it. And then at some point, we started building applications with it, and it was awesome. And Facebook said it works for them because they know what they are doing. But somewhere in our application team, a developer started to using that and thought, okay, they are doing this stream and defer up here. It makes everything faster. And actually, this runs, 150 milliseconds, super awesome. So I'm making it even faster. Down here is another list. Let's stream it too. And then we fire it, and damn it, it seems to be fast, but can you see? My complete UI is frozen because when we go now to logs, you can see that suddenly I made 20 patches into 3,653 patches, and my UI is constantly re-rendering, so I made everything worse. And that's where we resort defer and stream. So we have a solution to that. but just to show you how long it can take to implement such a complex feature or to come up with solutions to that. Before I show you how we solved it, because the idea is now that actually a defer is not defer me this thing, it's more like server, I want this deferred, figure out if it's good to be deferred, and then the server can drop defers. But we have a problem with that, and that leads actually to the next feature, which will also be included in the GraphQL spec, and that's about fragment modularity. So far, GraphQL was about minimizing network responses and reducing calls to our backend, but there are problems with it. So this is a typical fragment structure. So we have two fragments here, and actually fragment A calls fragment B, and what you can see there that I'm using 2 times the field symbol. It's a very simplified example here. And what we GraphQL servers, or I'm not a GraphQL server, but I implemented one. So what a GraphQL server does is actually rewriting that into a very small query. And we call that, we do that with a field merging algorithm. So we figure out you actually just want one time the field symbol here. And we also do one thing that we call defragmentization. So we remove all the fragments, all the information for it, because it doesn't matter for processing a GraphQL request. But that is a problem for us, right? If we have a defer like this here, and relay, for instance, has this binding to this fragment. So relay needs to figure out when this fragment is fulfilled. But if we defragmentize and remove all the defers to a thing, relay cannot figure out when a fragment is actually fulfilled, when the data is there for a fragment, when we can re-render sections of our UI. And what we actually want to do on the client side is reason about fragments in isolation. We want to do something like this. Maybe await the price details, our fragment here, and then use it. And this time I just want to print it to my console, but there could be other things I want to do with it. But I want to know when it's actually there. Maybe I want to do something like this. Ask, is price details not null, so I can use it now? Or do I have to wait for using it? So there are actually 2 solutions. That was the first one. I think it's kind of dead. It was kind of, this is the hack that you can use now if you use defer with the current version. Yes?
I have a question from somebody from online. Sven Q says, do you always have to do the combination to stream plus defer?
No, my expectations actually is that most people will use defer and just a percentage of people will use stream. Because stream requires you that you implement an async enumerable in your server, meaning you need to stream through to your database, otherwise a stream is just making everything slow. Because if you're fetching an array or something from your database and you have it in memory, why stream it? No, makes no sense. But if you have streamable data sources, so for instance, if you use Postgres, then you can stream through the database. It can make sense, but you need to implement something in your resolver to make it usable. But defer works with anything. It essentially tells you, okay, I want to defer execution of this graph, this section of the graph, and then the execution will essentially be spawned off. So we are essentially having then 2 promises in our server. One is the main execution and the other the spawn off execution. Branched is a better term. The execution is essentially branched. So with this fulfilled directive here, I essentially get just a true. But using it with an alias here, I'm now able to detect if a fragment is already fulfilled, because I can see that this section of data is now there. So this was the initial first attempt we did, but it's more moving to something like this, and this is a new response shape. and lets you suddenly alias fragment spreads. And that will lead to a new response shape. So I said initially that GraphQL is about reducing response sizes, but with this we duplicate data. But it also leads to a more natural data component, and that's actually where fragments should be. But we need more for that. So to have proper data components here, we are talking at the moment about introducing fragment variables. And then we have proper data components, because now we can alias a fragment here and then use it kind of like a function and to call certain kinds of data. So I'm reusing here the same price details, but with different parameters to get different price sections. And then this is really awesome to use. So, but this is just one part of it. The other thing is that we are also working on the response shapes of GraphQL to make defer work. And this is the current proposal, or actually is the previous proposal, because last week we decided to change that again. But the new structure is, this is actually the GraphQL response shape, you know, the data part. But now we have this pending, which tells you what parts are deferred. And if we don't tell you that something is pending, it's not deferred. And then there are incremental updates. That's how defer will work. And it's up to the client implementation to do something with it. OK, so let's change tracks here. And I show you one more cool feature. And it's it came actually by the guys from Yelp. They started building their application with GraphQL, and they were a bit disappointed with the outcome, or how they could use the GraphQL in the front end. So let me just give you a couple more aspects of modern application characteristics. So one is we want to iterate really fast between backend and front end. And that's one of the key features of GraphQL, because suddenly the backend developer says, here's the world, pick and choose and make your own requests. And the front-end developer can just compose the UIs around this data graph. Before that, it was like, I need this one more field. Can you please put that in your backend in this request, please? And then maybe the backend developers said, OK, here. It was like that before. Now it's so much more friendly with the front-end developers. Understanding improved. So it's about fast iteration. So, and it's also about strong contracts, about static typing in our front-end and backends. But in GraphQL, many fields are nullable. And that's because of something that we call the non-null propagation. Who does know then what the non-null propagation is in GraphQL? One, but I know him, so he knows it. OK, so this is something that people use GraphQL, but they don't realize what this is. So let me tell you. So let's say price is non-nullable. But suddenly something happens in our backend, and we have an exception. And what the GraphQL server does is null this field. And since the GraphQL server wants to send you some response, what it does is, OK, we're setting this field null, but then I cannot send this data to the user anymore. So I will just eradicate the whole selection set here and set nodes null. But if nodes is null, if nodes is non-nullable, then I also have to eradicate this selection set and set this field null. And if assets is null, yeah, then I have to eradicate everything, and I cannot send you any valid response anymore. So I send you just errors. And that is why most developers that develop graphs leave the composite types nullable, so that we have essentially a non-null error boundary, or an error boundary in our graph. So the people at Yelp came up with something they call null error boundaries. And it allows us to capture these errors and let the front-end developers specify that. Let me show you that. And again, we already implemented it. It's a draft at the moment, but you can try it already out. And this makes really a nice experience for the front-end developer, because let's say we have this data section here, and we have a couple of cryptocurrencies here, and the white paper is always non-nullable except for one time. So the front-end developer could say, in my component, I'm not allowing null for white paper. So while this shows it as invalid, it's up to my front-end developers that built actually Banana Cake Pop here. They couldn't keep up with us server developers, but it works. So what happens if I say that is non-nullable is actually that this non-null propagation will happen. And suddenly I get this error here. And I get unusable data. But what I want in my front end is actually nulling out just the element that violates my data contract here. And that's where I can now introduce a non-null error boundary here. And in this case, I want nodes to be non-nullable because I don't want to write all these null checks in my front-end component. So I say nodes is actually never null. But items could be null because if this is violating this, I want to capture this null error in my field essentially here. And then I can rerun that. I still get an error that informs me that one item violates my contract. But you can see I get all the data now. And just the invalid data is nulled. And now I can filter that in my client application, and I have my contract fulfilled, and I don't have to write all these petty null checks. Okay, so there are a ton of other proposals, and I will do another round of this and tell you about these awesome other features. They are in earlier stage in GraphQL. So we are talking about structs, metadata. One-off actually is pretty far. We also have implemented that, but I don't want to bore you with 1 hour of new features. So just as an outlook, there's a ton of stuff being created for GraphQL. And GraphQL is actually taking its biggest steps yet. So defer and stream will fundamentally change how you build applications with GraphQL and will make essentially for much faster front-end applications. And it's not through, fundamental revolutions. It's actually all these small steps that we take in GraphQL to get to that point that we get the revolution, that we get this new way of interacting with GraphQL. Thank you. And if you want to follow me, you can. I'm on Twitter, as I think everyone. But this is it. If you have questions, shoot. If not, we have beer. Oh, yes. And there's one more thing, because Jose is running the .NET user group.
We are together.
Yes, but I'm more a GraphQL guy. But yeah. So if you are in .NET, I don't know, some maybe, then.
Well, if you use some chocolate, you should.
Yes, you should. I'm doing .NET, but yeah, you can join us here. It's at Felfel. They do good cappuccino.
And good food.
Also do good food. So.
Yeah, good food also. So you can join here. Other questions?
When do you think, or when is it expected that these new features will be?
So defer is already implemented in a lot of GraphQL servers. Like we have it for 2 years already in the draft stage, but it's changing quite a bit. So it's a bit. If you use it now, you might have to update it every now and then. Relay is implementing it even for longer, Martin, 4 years or longer, because Facebook is already using it for 6 years. They just they didn't tell us how to implement it. That's the way. But I expect it in the next spec release, which should be this year. So I think we get it figured out this year.
Okay. Do you know like more specific, like half a year or at the end of the year?
So typically we do, I think the last spec release was May. It could be May, but it's not definitive, right? But I would expect it in the next 6 months. Wait.
When you were talking about the streaming and like these deferred fragments, how does it behave when there's an error? Because we were talking also about
Yes, because
the structure, the protocol.
that's very good question. Let me just go all the way back. So what you can see here in the incremental, we actually have here an error. You can see it's so an incremental is actually the same GraphQL response like we had before. So we also have standard errors. So you can have errors in the deferred parts without violating your whole request. You just get, okay, in this part we had an error.
So for example, in a stream that, for example, we have an array of, let's say, 10 items.
Yeah, there
So
could.
then, for example, the 10th item is going
Yeah.
to have an error.
It's an interesting aspect because so what we decided on in the stream part is actually if you had the request as a whole, you have this non-null propagation. So it could be that the whole result would be deleted. But incrementals also are implicit error boundaries, so null boundaries. So it could be that you get an error and this part is deleted, and then you have to figure out if you want to propagate this error. Yeah, but essentially, incrementals could have errors.
Yep. Tobias Tengler from the stream is saying that is the spec team already discussing the live queries? He assumes that the transfer work going into defer would speed up the spec process of live queries.
So live queries are a lot more complicated. We are talking about that actually at the spec group, but more like, okay, if we do that, that would also make live queries a lot easier to implement. Facebook actually has them in production. But they also said they struggled with a lot of the implementation details. They, in the beginning, had reactive data sources. They moved away from that, and the model is more like subscriptions now. But it's one thing on the agenda, but don't expect it to be next year. So it took us 6 years to figure out defer and stream, and we are almost there. So I expect it this year, maybe next, but I'm very optimistic that we get it figured out this year. Apollo is very involved also in that. They updated a lot of their components now this year. So the biggest GraphQL implementations now all have support for the latest spec iteration of defer. So I expect it this year.
I was just thinking, like, it's really great to have these features, but today I'm using like these caches, max age, like, you know, I'm leveraging gets to just deliver a lot of data quickly and cached. But how does that work together with defer and stream? How is this going to, and this is out of scope of the spec,
Yeah.
but I'm just questioning, how is this working like on the server side? How can you do this or still have the...
So caching is actually simple. So it's a query, and you could combine that, for instance, with cache control. And since defer and stream, I didn't mention that, but it's working over HTTP1. It's a simple get or post request while we're streaming. At the end, it's one blob, and that could be on your CDN. So that's very simple. So Facebook designed most of the features to work with HTTP1 because they might have clients that are very old, maybe in developing countries, but they still want to sell ads to these people. So why cut them off with demands for the newest tech or using sockets that don't work behind certain firewalls? So everything defer and stream is actually working over HTTP1. Essentially, it's so if we talk transport-wise here, we are talking about chunked encoding over an HTTP GET or POST request. And that's pretty simple. Every server can do that today. So it could be easy, but at the Felfel event in March, we have Tim Suchanek, who is CEO of GraphCDN, and he probably talk a lot about caching in GraphQL as well. So
I have a similar question about caching, because I mean, CDN caching, I think it's easier, but for example, the E tag, kind of equivalent of in GraphQL, I saw a proposal from Apollo, but I was wondering if there's been also any development there.
So there's the so Apollo is doing this cache control thing, so they're using the HTTP semantics. But depending on your application, it can be more complex. If you have authentication and authenticated data, caching can be more complex. And that's where things like GraphCDN tie in. I don't want to talk too much into that, because that's for the March event. But essentially what Tim and his team figured out is, okay, we need something like a client on the edge. So we essentially have a GraphQL client on the edge on a CDN, and they are using, I forgot, but not Cloudflare, but similar servers. They have and they're caching a client on the edge. So you have a session, bound GraphQL instance that is caching this data. So, but he will tell us a lot about that. I don't want to dive too deep into that. Yes, but there are solutions for that. GraphCDN, if you want to look it up.
Is it open for registrations, the March event?
No. So the Swiss Life event in February is open for registration, and I will probably publish the March event by the beginning of the next month.
Cool.
Yes?
One last question regarding this defer. I imagine it like a lazy directive. So if you have a huge website, let's say, and you scroll down and you want to defer the content that comes in, imagine like, I don't know, a huge marketing website.
Yeah.
So if you would do it in one request, it would probably also take a lot of time.
Yes.
So is this defer somehow also bound to this?
So the abstraction we use to talk about this is more like a promise. So, or a task in C#. So typically, you essentially spawn off this section of the graph and just say, okay, I'm encapsulating this in a promise, and I'm awaiting that. And whenever you finished, you tell me, and then I send you down to the stream. That is the conceptual model behind the defer and stream.
So from the front end, you cannot drive it directly.
Yeah, so that's the thing. You can, in the front end, ask for something to be deferred. But in the end, as I showed you, the server is in control and says, okay, it makes no sense to defer an ID that is anyway there.
But eventually the data will be loaded, doesn't matter.
Yeah.
So even if the user doesn't scroll down to the lower page.
Yes, so that is the thing. So everything that you defer, it will be there. You can cancel a deferred request, that is possible. So you can start a stream. Let's say it has 100 items, you're starting to stream, and then you're figuring out the user wants to this next page, then you cancel this request, and the server resources are disposed of, essentially. Okay? Awesome. Then we have time for the good thing of our meetup, and that is networking, drinking beer, and eating pizza if it arrives. Okay, goodbye live stream people. Yeah. It's deferred. It's deferred. Okay, you can stop the live stream. Stop stream.